So the next functional group that you want to know is also oxygen containing, the next two functional groups, and that is what we call an ester. Or let's start with the carboxylic acid, a carboxylic acid. So carboxylic acid contains an OH group, but of course an OH is an alcohol, but this is not going to be an alcohol if this carbon has a double bond O here. So acetic acid is one of the most easiest example you can remember, because this is something you should have seen in Gen Chem. This is called acetic acid because of this unit here. So it doesn't matter what you have attached to that carbon, as long as you have a C double bond O, and the carbon with the C double bond O has an OH, that is a carboxylic acid. That's a carboxylic acid. So an example of that would be so this is a carboxylic acid, and so is this. Let's say you have a structure like that. Then this makes this a carboxylic acid. So carboxylic acid is carbon. So that is that carbon here. I don't, again in skeletal writing, I don't have to show this carbon explicitly. That is implied. So this C double bond O OH is going to be a carboxylic acid. Alright. And the next thing that is closely related to a carboxylic acid is an ester. An ester, which sounds close to an ether, but make sure this is ether is carbon, oxygen, carbon. That is an ether. Whereas an ester is closely related to a carboxylic acid, where if we have a C double bond O and then an oxygen same as this, so it has the same arrangement as this, except instead of a hydrogen, if we have another carbon here, then this is what we call an ester. This is what we call an ester. So for example, if you're given a structure like that, that is the carbon here, this double bond O is here, and again as I told, you can have whatever you want on the other side, so that's the whatever you have on the other side. Here's an oxygen and here's a carbon, so this is a carbon, CH2, right? So that is an ester. An ester, again not an ether, an ester. You can also have cyclic esters. For example, you have a structure like this. Here's a carbon double bond O, and then you have an oxygen here, and then this oxygen has a carbon here. So this is a cyclic ester. Okay, so this is another oxygen containing structure. So far we have seen a ketone, and then an aldehyde, at least one hydrogen, and then you have seen a carboxylic acid, and then you have seen an ester. So these are all closely related. They all have the same C double bond O on them. So that's why these are studied together. So when you study their functional group chemistry, you will study them one after the other. But ketone is going to contain carbons on both sides. Aldehyde is going to contain carbon on one side and hydrogen on one side, or hydrogens on both sides. That's an aldehyde. Carboxylic acids contain an OH, and esters contain an OC bond. So these are all examples of the C double bond O containing structures. And of course previously we saw an alcohol and ether which contains oxygen as well, but they don't have oxygen with a double bond. Alcohols and ethers have oxygen with a single bond. So that is that. Next we're going to look at a few nitrogen containing functional groups. So this will be the nitrogen is the last of the functional groups I want to discuss. So if you have a carbon structure and then you have an OH, those are all hydrogens. I'm not going to draw them, so I'm going to draw a skeletal structure. So if we have a carbon oxygen bond and a hydrogen, we call that an alcohol. And if we have a carbon oxygen carbon, so let's say a structure like this, that is an ether. Now if you replace the oxygen with the nitrogen, be it here or here, it's called an amine. So for example, NH2, remember nitrogen is supposed to have 3 bonds, therefore you'll have an extra hydrogen. So this is an amine. Now unlike alcohol and ether, if you replace the hydrogen with an alkyl with a carbon chain, it is still considered an amine. So for example, if I give you this structure, that is still an amine. And if in fact I can replace all 3 sides with an alkyl chain, that is still an amine. So amines are fairly straightforward in that sense. You just need to call it an amine as long as it has a carbon nitrogen carbon bond, or carbon nitrogen bond only, nothing else. So that is an amine. So finally, the last functional group I want to discuss is when you have a carbon nitrogen triple bond. So for example, if you have an sp hybridized carbon, then it's called a nitrile. Sometimes they are also called as cyanides. So this is all the functional group I wanted to know for now. So let's do one more example. So let's say we have a structure. So this is an oxygen. So if we're given a molecule like this and we are asked to identify the functional groups in the molecule, so this is going to be an alkene. Here's an amine. And this is going to be a ester. And this is going to be a carboxylic acid. That is a carboxylic acid. So let's take another example. Alright, so if we have a structure like that, then this will be an alkyne. This is going to be a ketone. This is also a ketone, not an aldehyde. And this is an amine. And this is going to be a nitrile or a cyanide, NITRILE, nitrile or a cyanide. And that's all the functional groups you have in this molecule. So hopefully this makes sense, and if you have any questions, feel free to ask me about this in the next classes we will meet when we discuss chapter 2.